Good morning, everyone, and thanks for joining us for this webinar. Here's the agenda for the call today. We'll talk about the company overview from a Ribbon perspective, start that off with that, and then I'll hand it off to David Stokes for a quick preview of Ribbon's latest acquisition, ECI Telecom, the product portfolio that they bring to the table. So after that, I'll come back on and take you through the rest of the presentation that is based on VoLTE and analytics and stir shaken. Right, so that's the agenda for today. So starting off with the company overview, as I said, Ribbon recently acquired ECI Telecom, and David will talk a little bit about this. So the company is headquartered in the U.S. The combined company is headquartered in the U.S. with annual revenues of over $900 million at this point. And we have customers in over 140 countries and over 4,000 employees. So fairly a sizable company from a customer and employee perspective. And there's a lot of IP, that intellectual property that both the companies bring to the table as part of this acquisition. In terms of the broad categories that Ribbon plays in the service provider market, again, this is wireline carriers, wireless carriers, cable operators, wholesale carriers, the whole gamut from a service provider play perspective. There are about 8 different categories at a high level that we play in. We're going to talk about VoLTE today, but there are other areas that we play in. Starting off with 5G mobile backhaul that David is going to talk about from a packet and optical transport perspective. That is a big segment for us. We also play in the metro to access to core optical networking part as well from an ECI perspective. Also, since this is focused on service providers, but we do play in the enterprise market also from an edge SBC perspective to secure the enterprise network, and also from a UC perspective. UC could be on-prem, it could be in the cloud, but from an enterprise perspective, we do play in the UC space as well. Then the next segment is really, goes into security, nuisance calling, stir shaken, policy-based solutions. So we are a thought leader in that market, and I'll touch upon that in this presentation today. The other segments that we play in is analytics. We have a good play in the analytics sector, and I'll touch upon that today. We have a webinar coming up that goes into more details on analytics. But analytics is a broad term, and we'll exactly say what we do in the analytics space. So that is a big segment for us. And then Microsoft Teams, again, that's growing from an UC perspective. Microsoft Teams has been growing all around the globe in terms of number of seats that they've been selling. So our SBCs, the entire portfolio of SBCs, right from the edge SBCs to the core SBCs, have been certified with Microsoft Teams. So that is a big segment for us as well. So those are the different categories that we play into from a service provider perspective. With that, I'll hand it off to David Stokes to take us through a quick preview of what ECI Telecom has to offer from our from our product portfolio perspective. David?
Thank you very much, Ram, and good morning to everybody. I'm really excited to be given 5 minutes to speak to you about the feature-rich packet and optical transport portfolio that the merger of ECI has brought us. In the diagram here, you'll see a simplistic representation of where this packet and optical transport portfolio fits. On the left-hand side, you see user devices, laptops, phones, the like, and of course an ever-increasing number of things that make up the Internet of Things, which in turn power the move to everything going smart grid, smart homes, etc. These devices and things need to be connected to applications and services in the core of the network, shown on the right. This connectivity starts with access networks. Today, these are a mixture of wireline and wireless, and also a mixture of legacy technologies like SONET, 2G, 3G, and new technologies like PON, 4G, and 5G. The traffic from these access networks is then aggregated together and transported to the core of the network. It is this aggregation and transport that our packet and optical transport portfolio is optimized for and where we fit. And that is made up with an optical backbone and then packet technology that sits on top of that. In the wireless access network specifically, this connectivity is called mobile backhaul. and our 3G and 4G mobile backhaul solutions have been mass deployed in large and small networks across the world. But we have not stood still, and our solutions support the transport required to make 5G a reality. So you can deploy our transport solution for 4G networks today, knowing that it will also support 5G when you need it to. So Ram, can you move to the next slide, please? So briefly, to explain the role that transport plays in wireless networks. The 4G transport architecture, pretty much identical to the 3G or CDMA one, but just with extra capacity and being more packet orientated, the transport network is relatively static and used to connect monolithic blocks of functionality, the EPC, the radio, etc. Traffic from the radio equipment, or E-node Bs, is collected by the cell site routers and backhauled to the evolved packet core, or EPC, that sits in the core of the network. In this picture, we show a network that is big enough to require traffic to be consolidated in multiple mobile switching centers, MSCs, and then passed over the long-haul network back to the EPC. That will vary depending on the size of your network, etc. But this is pretty static network. And the backhaul connectivity is nailed up, with capacity defined during design phase, which of course can be modified, but that requires a full plan design build cycle. So basically, you nail up the capacity, it stays there, the connectivity is the same. In this picture, I don't talk about voice, that what the rest of the guys will talk to today, but this is served by either the existing 2G or 3G infrastructure or by using voice over LTE. Also in 4G, we start to see, not shown on the picture, the introduction of small cells where radio heads and their associated electronics called baseband units are separated. The connection between these is referred to as frontal. If we move to the next slide, Ram, I'll explain a bit more. With 5G, everything changes, or will change eventually. I say change eventually because the vast majority of the current 5G deployments are really only providing enhanced mobile broadband. And most of these are doing this in a way that reuses the existing 4G network and 4G network architecture, and this is referred to as non-standalone. However, a fundamental change occurs when you move to support advanced services like augmented reality, IoT, or to address new markets with mission-critical transport needs. Network functions stop being monolithic, and instead they become virtualized and disaggregated. You instantiate them when and wherever you need them, and with the compute power they require to do the job they need. They then are as quickly removed or downscaled as the need is removed or reduced. So in the diagram, the radio now is split into three components: a radio unit called an RU, a distributed unit called a DU, or a centralized unit called a CU. These can be geographically distributed or co-located as required. In the core, the EPC now becomes virtualized and disaggregated as well, allowing the component parts of this now virtual EPC to be instantiated wherever they are needed. This is an essential enabler for the control and user plane separation, or CUPS, required for efficiently handling the mass connectivity required by mass machine type communications, or IoT, as I mentioned before, which is the driver behind making everything smart. And whereas services like augmented reality that require ultra-low latency need the ability to run processing software or multi-edge compute, or MEC, located at the edge of the network of the services require that processing to still be in the core. So you start seeing regional, local data centers and compute located right at the edge. And again, that is turned up and down whenever it's required. And to make things even more complicated, all of this has been done in real time as services are created, deleted, or physically moved. This is, after all, a mobile network. So what's this to do with transport? Well, a transport network now must dynamically track all of these functions and provide the right connectivity with the right capacity at the right time. So no longer static, it's extremely dynamic and has to follow these functions as they are turned up, turned down, and wherever they're located. In addition, this transport network must also be deterministic enough to meet the strict SLAs demanded by mission and business critical services. You can imagine autonomous driving or remote surgery require unbelievably high reliability and low latency. The network must also be secure enough to protect against malicious attack. Finally, with all the 5G services having such vastly different needs, it becomes impossible to use a single homogeneous transport network. So instead, we have the concept of network slicing. In this approach, each network slice is optimized for the needs of the service it transmits and is built up of the components of the whole physical network. Our packet and optical transport solution provides the programmable, dynamic, deterministic, secure, sliced transport needed for all of this 5G functionality. So this enables you to deploy our transport network for your 4G needs or your early 5G needs today with the confidence that the network is software programmable to enable 5G features as and when you require them. And Ram, on my concluding slide. So basically, we have a number of elements from our complete Neptune packet portfolio that have been optimized for this mobile backhaul transport and particularly 5G. These are highlighted in blue. They provide advanced synchronization, hybrid mechanisms that are written here. You don't need to know at this point. We will explain a lot more detail in our next webinar. Underpinning this packet transport portfolio, we have our optical portfolio called Apollo, which is used for low latency, bulk and long haul transport of all this packet transport. So thank you very much for that brief minute. This was just a taster. If you want to know more, we'd be happy to talk to you, and we are running a webinar on the 8th of April, which will specifically focus on the transport for 5G.
Okay, thanks, David. So as David said, this was like a quick preview on the optical and packet transport from the ECI side of the business. And we have a webinar coming up on April 8th, where David and others will take you through the details on the optical side of things. So let's get back to the VoLTE side of the presentation. So again, I want to look at multiple aspects of voice over LTE here. So Ribbon plays on the peering side, it plays on the access side, and it does play on the analytics side as well. So we'll take you through these independent components of IMS. And if you have any questions along the way, just go ahead and ask me. So in terms of the IMS network, again, just stepping back a little bit, the whole transition from 2G to 3G to LTE, happened over time. And if you just look at the voice side of things, when it was 2G and 3G, the voice was really a separate component, and it was not merged in with the data. The data used to go in a separate channel, voice was in a separate channel, and there was not a good lot of spectral efficiency because they were using different spectrums and so forth. But with the advent of LTE, now the data and voice are combined into one IP infrastructure. So that leads to a lot of good things from a service provider perspective in terms of saving spectrum from their perspective, which is expensive, and also from an end user perspective, they can get to see new services, high quality voice and so on. But the key point of LTE is now data and voice ride on the same IP network, right? So that's the key point of LTE. So when voice rides on LTE, which is voice over LTE, there is an IMS network that sits behind the RAN, the radio access network, that really deals with voice. And there are different components of IMS that we're going to talk about here, but just quickly at a high level, there is an access side of IMS, there is a peering side of IMS that you peer to other networks, and then there is the analytics side or the operation side of IMS. So we'll touch upon each of these different components. From a Ribbon perspective, Ribbon plays at the edge of the IMS network. So this is on the access side from subscribers. This is on the peering side with other networks. So we play at the edge of the network, which is where you need security. You need interworking because different IMS networks are different. So you need interworking capabilities. You need roaming capabilities when calls roam from one network to another. And then you need things like emergency calling, which is key to any network. So we play at the edge of the network with our different elements that I'm going to talk about today, but the key things are security and interworking. So if you look at the different components of IMS, and we have kind of layered on top the ribbon elements that correspond to those IMS elements, we have our core SBC, the ribbon SBC, that plays multiple roles in the IMS network. It can play an access gateway role. It can play a proxy CSCF function. It can also play an IBCF function, which is more on the peering side. It can play a transit gateway function. So the SBC, takes on different roles based on the different components of the IMS architecture. Right? So that is the SBC that acts mostly on the access and the peering side of things from a security interworking perspective. We have a product called the PSX that is our centralized routing engine that plays the role of a BGCF, which is a breakout gateway control function. So when calls have to leave the IMS network, go to a different IMS network, or break out to PSTN, then use a function called the BGCF, and the PSX plays that role. We have our C3, G9 gateway and gateway controller functions that map to the MGCF and MGW functions of the IMS. So we have different functions that map to different functions of the IMS, but the key point is we play at the edge of the network where you need security, scalability, interworking as the key aspects of the IMS capabilities. So I talked a little bit about the SBC that provides the peering and the access functions. The gateway and the gateway controller provide the media gateway and the MGCF functions when you have to break out into PSTN. The PSX, our centralized routing engine, provides the BGCF functions, and also it can act as an enum server as well. But basically breaking out calls into other networks. It could be IMS networks, it could be PSTN networks, but the breakout function is provided by the PSX. The analytics solution that I'm going to talk about towards the end of the presentation comes in and provides the overarching solution from a troubleshooting perspective, from a security perspective, and also from a monetization perspective that covers the entire IMS architecture here. And our virtual mobile core functions as an application server from a session continuity perspective. So these are the different elements that form the core of the ribbon solution when it comes to IMS. So let's get into some of the details. I've broken down the sections into peering, access, and roaming, so you get to know each of these sections a little bit closer from an SBC and a PSX perspective. So first up is the IBCF, which is a peering function. So IBCF is a border control function, and it comes along with the transit gateway. IBCF is a signaling function. The transit gateway is a media function. But both of these functions are integrated within our SBCs, so you don't really need two different boxes if you want to think about that way. The IBCF and the transit gateway are really bundled into our SBC solution. So the IBCF and the transit gateway, they basically interconnect different IMS networks. So when you want to go from one IMS network to another IMS network, either of the same operator or a different operator, you need to have an IBCF and transit gateway to provide the security, to provide the topology hiding. Like you don't want the other network to know about the internals of your network. So you want to provide some kind of topology hiding. So this serves as really the entry and exit point of an IMS network from a security perspective. It also does other types of interworking, SIP interworking, IPv4 to v6 interworking. You know, one network might be v4 address space, the other network might be v6 addressing. So this provides the interworking between v4 and v6. So think of the IBCF transit gateway as an interworking and security functions that connect multiple IMS networks. So the ribbon SBC provides this capability as an integrated IBCF and transit gateway function. So in terms of roaming, and I have a section on roaming, but the IBCF also helps in providing the roaming capabilities for inter-IMS NNI connections. So inter-IMS NNI is basically connecting one IMS to another IMS network, and in the roaming scenarios, the IBCF is involved in the roaming call flows, and the ribbon SBC provides those capabilities. And further than that, the preconditions, you know, if you want to reserve quality of service-based resource reservations for a call, those preconditions are supported on the IBCF, and it does interwork with those parameters as well. The IBCF also has support for a bunch of other things. So we talked about roaming. RCS is a key capability that IMS enables, and RCS is the play that you make against the over-the-top players. The over-the-top players are coming up with cool functions like instant messaging, like collaboration tools, and so on that runs over the top on the data side of things. The service providers, if they want to have a play at the over-the-top functions like UC and instant messaging, RCS is the IMS way of doing this. RCS provides support for instant messaging presence. It provides capabilities for file transfer and so forth. So RCS basically is comprised of MSRP, message session relay protocol, where you can exchange messages between different devices, almost like instant messaging. And RCS has other capabilities like video sharing and file transfers and so on. So the Ribbon SBC supports RCS capabilities from a session perspective, from a interworking perspective as well. The next section is about MMTel, which is multimedia telephony. These are supplementary services that IMS offers, things like call waiting, things like presence information, call barring. There are like 15 to 20 different supplementary services that MMTel offers, and the Ribbon SBC supports these functions from a pass-through perspective, also from an interworking perspective. So that is from a services, these are things, RCS and MMTel, that ride on top of IMS. So once you have your VoLTE network, your IMS network, how do you make money? How do you monetize the network? So RCS, MMTel, these are the functions that ride on top of IMS where you can monetize the network. The SBC also supports the billing interface, which is a standards-based RF interface to do billing for invite messages, which are call or voice-based messages, but also non-invite messages like message or MSRP, which is for not for voice, but for instant messages, right? So you want billing for both voice kind of traffic, which is kind of the invite messages, and then you want billing for non-invite, non-voice traffic, which is instant messaging, presence, and file transfers, video sharing, and so forth. The last piece I'll touch upon on the next slide, which is Lawful Intercept, is a key part of any network, and it is a key capability that IMS offers as well. So Lawful Intercept. So here's where when a warrant is issued to tap a call, it could be from a calling party, it could be a callette party, but if a particular call is to be tapped based on legal warrant that's been issued, then operators have to comply, and different countries have different regulations, but operators have to comply with that warrant, and they have to tap the call and send the signaling and media messages to an intercept server, and then the legal authorities take over from that point on. But the operators are required to have a capability to intercept legal calls based on legal warrants. So Lawful Intercept, there are different flavors. The original Lawful Intercept was based on the packet cable standards, which came from the cable industry. IMS kind of tweaks it a little bit. So what IMS does to the standards-based Lawful Intercept is that it requires encapsulated media and signaling packets. So in a traditional Lawful Intercept, which includes an SBC that sees all the signaling and media packets, when a call is supposed to be intercepted, that particular call's signaling and media packets are then relayed to this intercept server, which can then take it for further processing, right? So when a call is intercepted, the signaling and media streams are duplicated, right? The signaling and media streams are sent to the actual destination, but at the same time, a duplicate of the signaling and media streams are sent to the intercept server. So that is Lawful Intercept. Now, in the IMS case, you're not just supposed to send the signaling and media streams, but you're supposed to send the encapsulated packet. So you're supposed to send the complete signaling and media packet, including the IP header, to the intercept server. It's not just the content, but you've got to send the headers as well as part of the complete packet for signaling and media. So the Ribbon SBC has support for the IMS type of legal intercept as well. We do support audio streams-based intercepting, so we send the audio stream, a copy of that, to the intercept server. There are different types of intercepts you can do. You can do the intercept based on numbers, like calling or callette numbers, or you can use based on the SIP URI. So we look at the entire SIP URI and match that, and if there's a match, we intercept the call. From a security perspective, the signaling packets that we send to the intercept server could be encrypted with IPsec tunnels. So we can use IPsec tunnels between the SBC and the mediation server so that the signaling packets are encrypted as we send them to the mediation server. The signaling is sent through TCP, and you can have IPsec tunnel to kind of encapsulate that. The solution, the Lawful Intercept solution, from a Ribbon SBC perspective, has been interworked or validated with a couple of vendors, mediation server vendors, namely Verint and Nudimaco, which are pretty kind of widespread in the industry. And we interwork with both of these players. And if you need more information, we are happy to get you that information. But Lawful Intercept is a key component of IMS, and the Ribbon SBC complies with the IMS flavor of Lawful Intercept. Okay, so that was the first section, was more from a peering capability, the IBCF transit gateway capability, where you interwork across different IMS networks. So you're on the peering side, where security is important, interworking is important, topology hiding is important, and so forth. Now let's get into the access side of things. So from a voice over LTE access side of things, you're now talking about really interfacing with the end subscribers, the end mobile phones. The IMS calls it the user equipment here, the UEs. It's really the mobile phones that connect to the IMS network, right? So we are really talking about the access side of things here, which is a different problem when it comes to performance and scaling. It's a different problem statement, and the SBC is the element that really fits the role from an access perspective. So the Ribbon SBC plays different roles. As I said before, it could function as a proxy CSCF from an access perspective, interfacing with the end devices. It could function as an access transfer control function, which is really used in the single radio voice call continuity. I'll talk a little bit about that. So the ATCF is a role that the SBC can play. The SBC can also play as an eCSCF for emergency calling. The eCSCF processes emergency calls and sends it to the right public safety answering point. So the SBC is the first point of entry for emergency calls as well. So the SBC plays different roles, and I'll talk about each of these as we go through this presentation. So from an access perspective, let's look at first the P-CSCF capabilities. So this is the proxy CSCF function that acts as the first point of contact for an end subscriber when the end subscriber gets into the IMS network. In terms of the P-CSCF functions, when the end subscriber first gets into the network, it registers with the IMS network saying, I'm a valid subscriber, here are my credentials, and the P-CSCF kind of, I think I have in the previous slide, the P-CSCF provides the authentication capabilities for the end subscriber to register to the IMS network. And we have different types of authentication. The IMS AKA is one way of doing it. This is the authentication and key agreement. The authentication then can be done with a SIP digest. It could be MD5 digest that the end subscribers provide to the SBC, and we authenticate end subscribers using the registrar function in the IMS network. It could be a SIP digest without TLS. It doesn't have to be a TLS connection, but we could still authenticate using a SIP digest. So there are different ways of authenticating users when they connect to the IMS network. So the P-CSCF is the first point of entry, so that's where the subscribers send the registration and authentication traffic. Once the subscribers are registered to the network, to the IMS network, then they can start making calls, voice calls, instant messaging, video sharing, whatever the application happens to be. They can start using the IMS network. But the P-CSCF is in the call flow from a access perspective to register the callers, authenticate them, and also to provide a layer of security from an access perspective to protect from DOS attacks, DDoS, and so on. All the functions of the P-CSCF, the Ribbon SBC supports. Here are a bunch of functions. There are other functions that we support. These are the highlights here. We do support globally routable URIs. So these are URIs when a user has multiple modalities of communication. A user can use a mobile phone, they can use a desk phone, they can use an app on their phone to talk to the IMS network, right? There are different modalities by which a user can get to the IMS network. With a globally routable URI, you can have one global URI for that subscriber, and we can route calls or messages to that subscriber. It doesn't matter which modality the subscriber is using, we can use the GRUU to get to the subscriber. So it's a globally routable indicator that we can use for the subscriber. In terms of identities, subscribers can have private identities, they can have public identities, and the subscriber can have one public identity that are mapped into multiple private identities for different use cases. We do support these mappings between private and public identities, and also things like wildcard public identity. Wildcards are typically used, for example, in a chat session where there are multiple people chatting at the same time. So for the chat group, you can have one URI, and it could be a wildcard, so you include multiple chats into the same place. So you can communicate to multiple or route to multiple users at the same time as part of that group. So you can use wildcard-based routing on the SBC as well. The IOI is the interoperator identity. So each carrier has its own identity. So when a call goes from one carrier to another carrier, the originating carrier is supposed to put in the originating interoperator identity parameter, and the terminating operator is supposed to put their own identity as well as part of the call. So the SBC is part of the call flow, and this could happen on the P-CSCF on the originating side for roaming calls. It could happen on the IBCF as well for peering calls, but we do support the concept of identity for the operators that we pass back and forth as part of the SBC call flow. The last bullet there is about IMS restoration procedures. This is used when something goes wrong with the IMS core network. So the core network here is the SCSCF, the application servers. Those form the core of the IMS network. So when something is going on with the core of the IMS network in terms of failures, the P-CSCF, which is the access function, can detect these failures. And that's what the IMS restoration procedure is. So we have a function in the SBC called the address reachability function, address reachability service, which basically is something like the SBC looking at the health of the IMS core network. So it constantly keeps pinging different next hop peers, and if a next hop peer is down, it blacklists that peer for a period of time. And then it keeps pinging, and once the peer comes back up, the peer is whitelisted. So the P-CSCF as part of the SBC function is looking at the health of the IMS core elements. It could be an SCSCF, it could be an application server. It monitors the health of the IMS core network and keeps a list of failed elements and list of active elements. So when a call comes in, it can route to the right element that is active and not go through the failed elements and causing thereby post-dial delays and things of that sort. So the IMS restoration procedure is really keeping track of the core network, the health of the network, which network element is up or down, and routing the calls around failures. So that's what the P-CSCF is supposed to do, and the Ribbon SBC complies with those procedures. In terms of the different functions that I talked about before, on the access side, the P-CSCF is absolutely one function that the Ribbon SBC provides, but there are other functions in the IMS context. The first is ATCF and ATGW, which is Access Transfer Control Function and Access Transfer Gateway. These functions in the IMS network deal with voice call continuity. So for example, an operator has an LTE network and they also have a 3G network. Or maybe another operator has a 3G network and a call is roaming from 3G to LTE. But whatever the case may be, there will always be areas of coverage that is not LTE, and you have to downgrade to a 3G connection, right? So what happens is when calls move from LTE to 3G or 3G to LTE, the other way around, you got to do a packet switch to a circuit switch handover or a circuit switch to packet switch handover, right? So the ATCF and the AT gateway function anchors the call in those situations where a call moves from the packet switch to the circuit switch side or the circuit switch to the packet switch side. We need to migrate the connection from one network to another network, and that's what happens with the ATCF. So all of this happens in pretty quick succession because you don't want to tear down the call. You want the call to be up, but you want to do the migration fairly quickly. So you want to anchor the media, but do the migration from one network to another network fairly quickly so nobody notices that there's been a handover, while still maintaining the egress leg of the call. The egress leg of the call to another subscriber that doesn't know that there is a handover happening on the ingress side. So the SBC is the component that functions as a ATCF and AT gateway that anchors the media and does the switching on the ingress side without notifying the egress side. So the call stays up and there is a minor disruption because you're changing the network, but then it's not noticeable. So that is done by the ATCF function, and the ribbon SBC, it's integrated within the ribbon SBC. The next function is the emergency call session control function. So this function handles emergency calls. And there are different types of emergency. It's not just 911, there's one type of emergency. In the case of IMS, you can have different types of emergencies as well. So as part of the IMS, there are categories of emergency calls in terms of ranges of numbers or in terms of services, in terms of the URIs that come into the network. We can categorize them as an emergency call. So it's not just a number-based categorization, it could be a type-based categorization of an emergency call. So once we determine a call to be an emergency call, the ingress SBC, which is the P-CSCF, needs to communicate with the E-CSCF, which is the emergency function that will then route it to the appropriate public safety answering point. And in this case, in some cases, you may know who the caller is from a subscriber perspective. In some cases, it might be a unknown caller, but in either case, you got a complete emergency call. So the P-CSCF and the E-CSCF act together. In some cases, you may need to talk to a location function, location retrieval function, to find out the location of the subscriber before you get to the nearest public safety answering point. So all of this is done in the P-CSCF and the E-CSCF, and the two functions can be integrated on the same SBC. It could be on different SBCs, but again, the SBC is the function that maps to the E-CSCF component in the IMS network. The last is kind of the combination of the first and the second. So this is an emergency access transfer function. So let's say there is an emergency call, but at the same time there is a handover happening from the packet switch network to the circuit switch network. So you got to still do the transfer from one network to another, but keep the emergency call up so you can terminate the call to the right PSAP for them to handle the emergency call. So it's really an emergency call that's being handed over from one network to another. So all of these functions are capabilities on the SBC. If you want to put them on the same SBC, that is possible. If you want to split them into different SBCs, that is possible as well. But the ribbon SBC complies to all of these functions that the IMS network needs. So we talked about the peering network, where the SBC plays the IBCF role. We talked about the access network, where the SBC plays the P-CSCF role, the E-CSCF role, the ATCF role from a voice call continuity perspective. So we looked at the access and the peering. Now let's look at some roaming scenarios to finish off from a VoLTE perspective. So roaming is when calls roam from one network to another, from a different operator to the home network. Could be LTE, could be 3G to LTE, could be any different, any type of combination thereof, right? So what is needed on the SBCs to make roaming happen successfully is the SBCs on both sides. The bottom is the visited operator and the top is the home operator. So on both sides, let's say the subscriber has moved into another country and is roaming into the home country. So there is a visited operator in the visiting country and there is a home operator in the home country. There are SBCs on both sides that act as IBCFs, because as you remember, IBCF is the peering element when you have to go to a different IMS network. So the SBCs have to anchor the call from a signaling and media perspective, and then provide interworking functions in terms of registration relays, in terms of roaming functions that I'm going to talk about in the next slide. In terms of the roaming itself, it started off with S8 based roaming. S8 is an interface in the IMS network, S8 home routing based roaming capabilities. But the S8 HR type of roaming was good in the beginning when not a lot of people had IMS networks. So there was no dependency on the visiting network to be IMS compliant. So only the home network had to be IMS compliant for S8 home routing based roaming scenario. But the problem was every call had to be routed back to the home network to complete the call. So for example, let's take an example where a US-based subscriber is visiting Singapore. So he's visiting Singapore, he's connected to the visiting network in Singapore, and he's making a call to a local Singapore number. So now with S8 HR routing, the Singapore to Singapore call has to come all the way to the US and then go back. So the media is kind of looped back all the way to the US. There's a lot of delay, there's quality issues and so forth. So while it was good in the beginning, it is not good from a subscriber experience perspective. So that's where the local breakout-based roaming scenarios came up, and this is the optimal media routing based on 3GPP that doesn't always anchor the media in the home network. As you can look at here, I'll just go through the high-level details here. So we have the call happening in Singapore, and the signaling has to go through all the way to the US to set up the call, but the media doesn't have to go all the way to the US. The media just goes from the visiting operator to wherever the destination carrier is. It doesn't get looped back all the way to the home carrier, which is this blue line here. So the SPCs, for their part, there's a function called the TRF, the roaming function. The SPCs can insert the roaming function's address or domain name into the call so that the media, the blue line, doesn't have to go all the way to the home network. It just bypasses the home network and just uses the visiting network. So the optimal media routing is part of the SPC function as well. So that completes the SPC piece of things from an access, peering, and from a roaming perspective. The next element I'm quickly going to touch upon is the PSX, which is our centralized routing engine. The PSX acts as a routing engine for the entire network from a routing perspective, least cost routing perspective, from a number translations perspective, local number portability, toll-free translations. So the PSX acts as the core routing engine for the entire network. It could be ribbon elements. It could be non-ribbon elements. The PSX supports those from a routing and translations perspective. Now, when it comes to IMS, the PSX functions as a BGCF, which is a breakout gateway control function. And the BGCF basically interworks between different IMS networks. It interworks with PSTN. So when a call has to break out from the IMS core into PSTN, the BGCF is the function that routes calls between the IMS core and the PSTN network. So the PSX functions as a BGCF in the IMS network. So with that, let's quickly get into analytics. We're getting closer to the end of the hour here, so I'll quickly get into analytics. So we looked at the call processing aspects of IMS in terms of how do we do roaming, how do we do emergency calling and all that. So that's all based, the base call processing functions of the IMS network. Now let's look at the analytics function, how it applies to IMS networks. So IMS is very good architecture to go to the next level in terms of offering services, but also introduces complex call flows. So if there is an issue in the network, how do you troubleshoot these complex call flows? And that's where the analytics portfolio comes in from a ribbon perspective and helps you with the operationalizing the IMS network. So there are three components to the analytics portfolio. There's an operation segment, there's a security segment, and there's a monetization segment. So from operationalizing the IMS network, when there are issues in these complex call flows, how do you quickly get to the root cause? So that is what the operational side of analytics provides. And analytics is basically looks at a lot of data in the network and provides the most probable cause of an issue, so you can quickly drill down to the issue and fix any issue so that customers are not impacted. So that is the operation side of things. Again, we have a detailed analytics webinar coming up, so we'll get into some of the details in that webinar. I just want to give a brief kind of quick preview here. So that's the operation side of things. In terms of security, obviously any network needs security, and IMS networks have secure SPCs at the edge of the network, but also we need to monitor these elements so that we can look at DOS attacks and TDOS attacks happening throughout the network in a distributed fashion, so that analytics can look at this and provide quick indicators on if something is about to happen even before it happens. So security monitoring is a key aspect of analytics as well. The third aspect is more from a monetization perspective. So you have invested in the RAN side, you invested in the IMS voice over LTE side. Now how do we make money with RCS? How do we make money with MMTEL functions and so on? But also how do we look at analytics and monetize that? So we can look at user behavior, for example. You can look at subscribers, what they're accessing, what is relevant for a particular subsection of your network. We can provide that type of content that people are interested in and monetize and market the network from that perspective, from a user perspective. So analytics can help with operations security, but also from a user behavior perspective, it can help you monetize your network. So that is the analytics component of IMS. I'll quickly touch upon stir shaken before we get to the end of the webinar. So stir shaken is pretty hard from a regulatory perspective in the US and Canada, and we're also seeing interest in the rest of the world as well. So stir shaken is basically bringing trust back into the phone network. There's a lot of spoofing going on, and stir shaken is the way we can authenticate calls and verify calls before we let it go through the network to the terminating site. So stir shaken is a way to certify calls and bringing back trust into the phone network. So the same SPC and the PSX infrastructure that we talked about as part of the IMS network with the P-CSCFs and the BGCFs and so on, the same components also are also components of the stir shaken network. So in the stir shaken call flows, what we need to do on the originating side is sign calls, and on the terminating side, we have to verify calls. So the SPC is the right place to do the signing and verification because the SPC is a border element, and you sign and verify calls at the border of your network. And this is a SIP-based network is where stir shaken applies to. So the border of a SIP network is where you need to do the signing and verification. So stir shaken really applies to the SPC in your network. So as part of call processing, the SPC and the PSX is the routing component of the SPC. The SPC and the PSX, as part of routing the calls, on the originating side, they need to sign the call. On the terminating side, they need to verify the call. And they do that by looking up a service called the STI service, the Secure Telephony Identity Server. This is the server that holds on to certificates that are used in signing and verifying calls. So the SPC and PSX, as part of call processing, they'll bring in the STI server to sign and verify calls. Now this solution, this whole solution, the signing part of the solution can be on-prem in your network, or it could be hosted in a Ribbon-hosted cloud. So we offer both options. You can have your signing components in your network, or we can host it for you as a service. So the SPC in your network can query the cloud-based Ribbon solution to sign and verify calls. So we provide the flexibility in terms of deployment models, both on-prem and cloud-hosted models. So we talked about stir shaken. So stir shaken helps in mitigating robocalls and spoof calls. So when somebody fakes a calling number, stir shaken can identify that and flag that. Now that takes care of some parts of the robocall issue and the fraud call issue, but there are still going to be fraud calls that are not spoof calls that stir shaken takes care of. So stir shaken takes care of about 20 to 25% of robocalls. The remaining 80% of the robocalls and fraud calls, stir shaken cannot mitigate those. So we really need a robust analytics architecture to take care of the rest of the robo nuisance and fraud calls, and that's where the Ribbon Identity Assurance solution comes in, which is a robust analytics solution in the cloud that basically looks up different information, gets data sources from different places, both from your in-network analytics. So analytics is an in-network component that provides data into this cloud infrastructure, but also gets a lot of data from third-party sources, could be crowdsourced databases, could be FCC blacklisting, could be the carrier's own blacklisting. So it gets data from third-party sources, it gets data from your on-prem analytics, and it crunches all that in this cloud service in the center and provides a real-time metric on a call-by-call basis on if a call is supposed to be a fraud call or it's supposed to be a good call and so on. And that it does that by providing fraud scores on a real-time basis on a call-by-call basis. And if a call is supposed to be a 90% probable fraud call, then you want to take certain actions based on that. Maybe you want to block that call. If a call is supposed to be a 50% fraud call, you may want to send it to voicemail, or you may want to provide an indication to the end subscriber using the caller ID that it could be a spam call. Or if it's a 20% fraud score, maybe you want to just let the call go through, right? So this identity assurance solution gets data from different sources from your network and from third parties and consolidates all that information from a real-time perspective has machine learning and artificial intelligence capabilities to dynamically adapt to the fraud scenarios and provide a fraud score on a real-time basis to your call processing entities. So this is what is needed to completely get rid of robo and fraud calls in your network. Stir shaken is one component that is absolutely needed. It takes care of the low-hanging spoof call issue, but then you need a robust architecture, analytics architecture that rides on top of stir shaken to provide the complete mitigation from a robo and fraud call perspective. And that's where the Ribbon Identity Assurance comes in, and we'll talk about more about this in the next webinar on the analytics, in the analytics webinar coming up. But basically, just to complete this picture here, so we have the call processing components on the left here. We have the in-network analytics that detects fraud and robo calls in your network, and there are third-party and industry sources on the top. We have the stir shaken signing component to sign and verify calls, spoof calls, to detect spoof calls. And then we have this identity assurance component in the center that brings all this together and provides fraud scoring on a real-time basis. So this whole architecture from a call processing, analytics, and signing and verification perspective kind of completes the architecture both in an IMS context and in the non-IMS context. It completes the architecture and provides a secure calling network and kind of helps bring trust back into the phone network for consumers. So we talked about different aspects here, the IMS components from a call processing perspective, analytics that will help you with operationalizing your network, and then stir shaken and identity assurance to secure your network and bring the trust back into the phone network. So again, why Ribbon? Why should Ribbon be part of your network to do these functions? From a credibility perspective, Ribbon is deployed in many Tier 1 and Tier 2 networks around the globe. We are a credible partner from a VoLTE perspective. We have installed multiple deployments in the wireless space, in the IMS space, both on the interconnect side and the access side. And we are a thought leader in the analytics space when it comes to operationalizing your network in terms of security and data monetization. And then from a stir shaken and identity assurance perspective, we bring the trust back into the phone network by signing, verifying, and providing a robust analytics architecture. And with the ECI acquisition that David kind of talked about, the product portfolio, that brings in the optical and packet transport, kind of the physical layer. So we kind of complete the picture from the layer 1 to layer 7. We complete the picture from a Ribbon perspective. So that is the holistic solution for VoLTE from a Ribbon perspective, all the way from optical transport to the application side. With that, I'll turn it over to Elizabeth Page to take us to conclude this webinar.
All right, thank you, Ram, very much. And I think Jamie, there was some questions coming in on the PSX that you were going to ask.
We did. Hey, Ram, a question came in around the slide you had up on centralized routing on the PSX, saying that we had kind of covered that a little bit quickly, and questions around what other things can it do in terms of routing?
Absolutely. So I apologize for kind of quickly breezing through this, but the PSX is a centralized routing engine, and as I said, it's vendor agnostic. It can work with Ribbon devices, it can work with non-Ribbon devices, and it's a network-wide routing engine that provides routing capabilities. It provides least cost routing if you want to put in rate sheets and talk to multiple vendors from a low least cost perspective. It provides that capability. It provides policy capabilities if you want to route differently during different times, differently for different calls and different capabilities. It can route differently. It also packages in the number translation support, whether you want to do local number portability, calling name translations, toll-free translations. All of that could be embedded within the PSX. So the PSX can host all of these tables on the PSX, or it can go out to an external database and get these translations, whether it's local number portability or toll-free. It can go out to a variety of databases and get that information back. So again, we give you the flexibility of keeping these routing and translations locally on the PSX, or we can go out and query another service and get the translations back. But in terms of scale performance, in terms of the capabilities, the PSX has been deployed in over 200 networks around the globe and a lot of big enterprises as well, as a centralized routing engine that takes care of both the ribbon devices and non-ribbon devices. So you can really centralize your policy, your routing and translations into one infrastructure, as opposed to keeping it distributed across many different devices.
Perfect, Ram. Thank you very much for helping answer that question there. If you go to the last slide, I'd appreciate it. Perfect. All right. Well, thank you all for joining today, and thank you for Ram and David going through the details. As you can all see, we've already started a lot of the integration between the ribbon and the ECI teams, and we are all excited about what that combination can bring together for our customers. So thank you for being here. Given the nature of travel right now, we do want to make sure that we're doing a good job of communicating all of the updated product and solution developments that we have out to our customers. And the great news is we have a lot of technology to support virtual communications, so we will leverage that. And within that, we've created a series of webinars focused on the mobile networks. And the next one, as you can see here, is planned for April the 8th. And we'll do a deep dive. David gave us a little teaser today on what the ECI portfolio brings to the table, and we're going to deep dive into that more. We'll talk more about some considerations to make on your 5G deployments, how to avoid some challenges and some pitfalls, how to, that you may see with capacity and performance, but in parallel maintain network flexibility. We'll talk more about slicing in the transport network and also go into more detail about what is hybrid slicing. And we will be driving some communication out on what's going to be the requirements of some new synchronization needs for your network and how that's going to impact your transport network. So that's a little detail about what we'll go into on the April 8th webinar. After that, on May 6th, we will have another webinar focused in on analytics. Ram gave a little bit of detail here, and we will go into more detail. As you can see, the networks are becoming more and more complex, so any analytics you can have for your subscribers or your network is going to become more important. So we'll share more details on what we already have to offer there. And of course, if you have recommendations on webinars that you would like to see from us, just shoot me a note, and I'm at epage@rbbn.com, and we'll be glad to get those into the queue. And please join us on these webinars. Feel free to share the invitation out to peers in your company that you think may benefit from attending these as well. So thank you for joining. Lance, I will hand it over to you.
All right, thanks, Elizabeth, and thank you, David and Ram and Jamie for being on as well today. When we end here in a moment, a quick survey will pop up. We'd appreciate your participation in that survey, so feel free to fill that out. Later this afternoon, I'll be sending an email out with a link to the replay and as well the slides as well. So look for that later this afternoon, and also look for those invitations coming for the aforementioned webinars Elizabeth just went through. Again, we appreciate your time today. Thanks everyone for joining, and we will speak to you all very, very soon. Take care.